Welcome student to my YouTube channel Bharat Chem Study. Today we are going to study about the chapter 2 structure of atom for +1 class. In this video part 4 we are going to study about Rutherford model of atom, its drawback, Bohr model of atom and its drawbacks. So let's start with the topics. Rutherford model of atom. On the basis of his scattering experiment, Rutherford gave his model of atom as a heavy positive charge called nucleus is present in the center of the atom and electrons revolves around it in the circular path as shown. The centrifugal force balances the electrostatic attraction of nucleus on the electrons, hence electrons do not fall in the nucleus. The nucleus consists of proton and neutron and the mass of atom is due to the mass of nucleus and electrons have negligible mass. The positive charge on the nucleus is due to protons. The drawback of Rutherford model of atom. According to the classical electromagnetic theory, if a charged particle accelerates around an opposite charged particle, it will radiate energy. If an electron radiates energy, its speed will decreases and it will go into spiral motion and finally falls into the nucleus as shown. Similarly, if an electron moving through orbitals of ever decreasing radii would raise the radiation of all possible frequency, in other words, it gives rise to a continuous spectrum, but in actual practice, atoms give discontinuous spectrum, and if the electron falls in the nucleus, atom will not remain stable, and it was already told by the Rutherford experiment that electron will not exist within the nucleus. So Rutherford was unable to explain these things in his model of atoms. Bohr model of atom. To overcome the drawbacks of Rutherford model of atom, Bohr gave his model of atom as an atom consists of a small heavy positively charged nucleus in the center and surrounded by electrons. The electrons in an atom revolves around the nucleus only in the selected circular path which have a fixed value of radius and energy. These paths are called orbits. These orbits are associated with the definite energies and are called energy shells or energy levels. These are numbered as 1, 2, 3, 4, etc. or designated as K, L, M or N shell, etc. So here is the model. Here the first shell is called K shell, second shell is called L shell, third shell is called M shell and the fourth shell is called N shell. The electrons revolve in the circular orbits around the nucleus which are restricted by the quantization of angular momentum, that is, they revolve in orbits where the angular momentum of the electron is an integral multiple of h upon 2 pi or MVR, that angular momentum MVR is equal to NH upon 2 pi where h is Planck constant. These orbits are called stationary state because they have fixed value of energy. The energy of the atom has a definite value in a stationary orbit or shell. The electron can jump from one stationary orbit to another. If it jumps from an orbit of higher energy E2 to an orbit of lower energy E1, it emits energy in the form of photons as shown in the figure. This is the energy level E2 and this is the energy level E1. When electron jumps from E2 to E1, it emits energy in the form of photon as shown. The energy of photon is E2 minus E1. The wavelength of the emitted radiation is given by the Einstein-Planck equation, that is E2 is minus E1 is equal to h nu is equal to hc upon lambda, where nu is the frequency, c is the velocity of light and lambda is the wavelength. The electron can also absorb energy from some source and jump from lower energy level to higher energy level as shown. The energy of different stationary states or shells in case of hydrogen atom is given by the expression called Bohr formula, that En is equal to minus 2 pi square me power 4 over n square into h square, where m is the mass of electron, is the charge on electron, h is the Planck constant, where n is equal to 1, 2 or 3 depending upon the number of shell. Putting these values, the value of energy can become as En is equal to minus 1312 upon n square kilojoule per mole. For hydrogen-like particle like He2 positive, lithium 2 positive, which means that which is having the same electron as present in hydrogen, the expression for energy will be given as that En is equal to -1312 into Z square upon N square, where Z is the atomic number of the atom. The radii of the stationary state of the hydrogen atom can be given by that Rn is equal to A0 N square, where A0 is equal to 52.9 picometer and is the radius of the first shell. For hydrogen-like particle like He positive or lithium 2 positive, which have same number of electrons as present in hydrogen, Rn is equal to A0 N square upon Z, where Z is the atomic number. The velocity of electron in different orbital is given by the expression according to Bohr that Vn is equal to V0 into Z upon N, where V0 is equal to 2.188 into 10 to the power 8 centimeter per second is the velocity of electron in the first orbit. So these are the main formulas or main points given by the Bohr about his model of atom. Here a question arises why the electron energy is taken as negative, because we are taking En is equal to -1312 upon N square kilojoules per mole. The answer is that when the electron is at infinite distance from the nucleus, its energy is assumed to be zero. As the electron moves closer to the nucleus, due to electrostatic attraction, work is done by the electron itself and hence energy is released. Consequently, its energy decreases and it makes energy value less than zero, which means negative value. That's why the energy of the electron is taken as negative. The problems with the Bohr model. First, it violates the uncertainty principle because it considers electron to have both a known radius and orbit. The Bohr model provides an incorrect value for the ground state orbital angular momentum. Third point, it makes poor prediction regarding the spectra of larger atoms. It does not predict the relative intensity of the spectral lines. The Bohr model does not explain the fine structure and hyperfine structure in the spectral lines. It does not explain the Zeeman effect, that is, the splitting of spectral line in the presence of magnetic field. It also do not explain Stark effect, that is, the splitting of spectral line in the electric field. Sixth point, if the wave character of the electron is taken into consideration, then the path of motion of electron cannot be well defined. So the uncertainty principle rule out the Bohr idea of well-defined circular paths. Study the topics of this video. In next video, we will study de Broglie concept of Dune nature, de Broglie wavelength, uncertainty principle, quantum model of atom and numerical. Please like and subscribe the channel for the latest update. Thank you.